I want to talk to you about the Eiffel Tower and how this fits with ideas about media and process, which is the focus for the first part of this term. So you've looked hopefully at this website and had a go with the task sheet. And if you haven't attempted the task sheet yet, hopefully this will help you as you go through it. So the Eiffel Tower is a really iconic building, and it's really significant in terms of the history of architecture because it's this crossover point between where it is architecture and engineering. And this is the start of producing new forms in architecture. So we've looked at forms as in like the Greek orders, like the Ionic columns, and Roman arches, mentioned briefly, Gothic arches. And architecture through the 19th century tended to be a conglomeration or variation of combinations of those ancient forms of architecture. And as we go into the modern age, there is a desire from architects to reject those and to come up with new building forms. The big project in the 19th century is the desire to build upwards. It's expressed particularly in the newest type of building, which is skyscrapers, which start to appear around the same time as this is built. So the goal is to build high, to build big, and the use of engineering as a new design form is really important. So if we were looking at this photograph and didn't know what it was, we could think that we were looking at the start of the building of a bridge, not a architecture as such. Now, one of the things that's interesting in looking at how things are built is by looking at the scale of the project. And so this is a useful slide here saying how many parts, how many designs, how many engineers, how many rivets, how much iron, how many tons of paint, etc. were used in the making. And then also the duration, how long it took to build. To get some sense of the time period. So this time period here, 1887, is actually marking the centenary of the French Revolution. And this period is really significant because it's the context period for the era that we'll be looking at, which is from 1900. What we see in this slide is the goal for the building, which was to be built for the World Fair of 1889. The World Fairs were trade, they were manufacturing, they were culture, and the best of design. And each country would enter an exhibit. The Crystal Palace was the first of these big world fairs in London 20 years beforehand, and we'll look at that. But it's an important idea for this period. Each country demonstrating what they can produce. So as the host country, the Eiffel Tower is going to be the signature landmark for this event. So this is just describing a little bit about the brief for the tower. This slide here has a lot of information and it's really useful for us. So this is probably one of the most important slides in this website. And it talks about the pedestals and the arches, which is the base of the design. And it talks about, so that's in this paragraph here. And then this is talking about, with a quote, the design purpose, and that is that it is determined by mathematical resistance to wind. So anything which is really tall is subject to all sorts of forces, And so wind for something of this height is the most critical factor. The quote here from Eiffel himself is a really good explanation, quite technical, but a really good explanation of some of the ideas that lead to the type of design that it is. So when we're thinking about the way that something is designed, the process that's gone through to make it, what we want to see is a fit for purpose match. So using wrought iron girders, which will allow a lot of air to pass through, will reduce the resistance of the wind and make it stronger. So we're wanting to see that connection between the purpose that the design has to withstand wind, and then how that is expressed in the way that the materials are put together, the process that goes towards designing it. With architecture, and especially large-scale architecture, we get really interested to see how long did it take, how many people did it take to build it, and that sort of thing. This slide covers some of that, and it also shows you a really interesting thing of how they were building it. So they've got this sort of tracks up here, looks like almost like a little railway carriage, and the same thing here. And this was the way that materials were taken up and taken up the length as it was built. This slide talks about some interesting facts. So 18,000 pieces that go into the tower, and that the accuracy in terms of designing and construction down to 1/10 of a millimetre. So incredibly accurate. Now the tower is constructed off-site in the factory into sections, which are then placed onto the tower as it's being put together and then re-riveted. These rivet workers are probably the heroes of the project, and it takes 4 men to actually do one rivet to hold it together. This is incredibly labour-intensive work, and you can read here to see how it's done. And this is done 2.5 million times, which is a whole lot. This is also giving you some explanation about the use of concrete. So we've got iron and we've got concrete. So these are these new materials. And this has a little bit here talking about pressure. So 3 to 4 kilograms per square centimetre, which is incredible pressures that the tower has to withstand. We also see here mention of these metal caissons. So these are kind of boxes which are built, excavated into the ground. They then adjust the air pressure within them so that people can work underground, or often these are used to work under rivers or in rivers. It's incredibly difficult and dangerous work. Here we see mentioned that wooden scaffolding is used, and we can see some sections of wooden scaffolding. This is really sort of ancient technology. This is used through medieval period building Gothic cathedrals and so on, and also using cranes. But here the cranes are steam cranes. So this is a new technology that gives greater power in terms of the lifting capacity. And we also see the use of these sandboxes and hydraulic jacks as well. So some of the processes here in themselves are not new, but the methods of carrying out the processes reflect new technologies at this time. Because the Eiffel Tower is such a beloved icon now, it's really hard for us to understand that actually at the time people were like, no, don't build it, don't build it. So you might not be aware that there was all of this controversy and protest against the building of the Eiffel Tower. And leading it were the best writers and artists of the day. So here's an instance where the power of art sometimes gets it wrong. And I really like these drawings here, just showing technical drawings of methods of construction. So if you were writing about this with a task sheet for how this is made and the processes and the materials, a resource like this is useful. Charles Garnier, who designed the beautiful Opera House, describes is one of the people who is really vehement about protesting against the building of the Eiffel Tower. Now, the Opera House, the Paris Opera House, is described as a wedding cake of historicism. It has every possible decoration. It's extraordinarily beautiful, but it's a historicist building. And so it's not a surprise that he would reject something which is so modern looking as this, that looks like engineering. But the sort of insults that they are talking about are truly tragic street lamp. So no one talks about the Eiffel Tower like that now, I don't think. So the criticism against the tower eventually peters out because of its success. And in that first year, 2 million people visited the World Fair and would have looked at the Eiffel Tower and been absolutely amazed. One of the things about the Eiffel Tower that's hard to understand in our time is that when it was built, it was the tallest constructed structure in the world, and that it was the highest that you could get as a human being, really. So people who were going up there were suddenly startled to look down on Paris and see this bird's eye view. It wasn't possible from anywhere else at that time. And this last little section here is a really interesting discussion about some of the understanding that leads to the development of modernism. So Eiffel says this: I believe the tower will possess its own beauty, and that an engineer is equally concerned with beauty as an artist, and the link between elegance and harmony with durability and construction. He makes specific reference to the mathematics, the curvature, strength, and beauty of the building. So this is a really good piece of writing to support ideas about what modern architects are trying to do. A reaction point of view, which is the one that comes from the writers, painters, sculptors, and architects, who protest about the ugliness of the Eiffel Tower, expresses the disturbance that machinery and industry bring to ideas about beauty. So this idea of a gigantic black factory chimney and a barbarous mass humiliating monuments and belittling architecture speaks to a strong trend in the late 19th century that wants to go back to the beauty of a different era. So what we've got in this two different points of view here. One is the beauty of engineering and the beauty of a machine, and the other is the ugliness of that. And these are two quite strong trends that conflict against each other and help to shape the way that architecture develops in the 20th century. So just recapping quickly, this set of slides covers ideas about how buildings are made and how the way that they are made or designed and the materials that they're designed and made with will affect the outcome of the building, and that this is something that we will focus on in art history during this term.